cut wood problem in Java. Given an int array of wood representing the length of n pieces of wood and an int k, it is required to cut these pieces of wood such as that more or equal to k pieces of the same length are cut. So what will be the longest length that we can get? So this is the Facebook interview question. For the first example, if we give 5, 9, and 7, which describe the length of the wood, 3 pieces of wood, if we want to keep 3 different pieces which is equal to the same length, what would be the longest length that we can get? So in here for wooden 5, there is no need to cut it. For wooden 9, we cut it to 1 piece and we get 5 and 4 for different two pieces of wood, and for 7 we're gonna cut it to 2 pieces again and we get 5 and 2. So as a result we can get 3 pieces of 5 by this given array. For the second example, if we want to keep four pieces of equal length, if we ask what will be the longest length, if we consider as the first example lesser than 5, because in this time we are accepting for 4 different pieces, so we need to divide the wooden 5, wooden 9, and wooden 7, and in for the description we can get 4 different pieces of length 4. So the output of this example is supposed to be 4. The goal for this algorithm is achieving O(n) time complexity and O1 space complexity, which describes in space. So let's pause the video for a while and try to solve it yourself first. Right, welcome back. For suggested algorithm for this problem is using the binary search. Binary search in computer science, also known as half interval or logarithmic search or binary chop. To apply binary search, array needed to be sorted. For binary search, compares the value of the middle element of the array every time. Then according to the comparison result, it compares with another half again and eliminates half of the array every time until finding the position. If it finds the number in the array, then it returns the position. If the number is not found in the array, it returns -1 or the number itself. For the time complexity for this array is, in the worst case, by defining the result array each time and finding the last array defines the worst case. So because of we are get rid of the half of the array every time, we are decreasing the time complexity as in logarithmic, and 2 represent the half of the array. And while calculating the time complexity, it is a rule of thumb is removing the constant, so the binary search time complexity is accepted as log n. And binary search is faster than the linear search, and another information, hash tables are more efficient for searching because it's returns in constant time, but the binary search can be used to solve a wider range of problems. For this given array, let's search for 5. So we are dividing the given array for 2 pieces. The first array ends with 9, and we need to check for the first array because 5 includes in this first array. Then we keep dividing the array every time, and we are continue our search with the first array again because 5 includes in the first array. Then continue with searching with the latest array, then we are dividing the array in two pieces, and we are finding it in the second part, and we are returning the value of the index of the whole array, which is 2. So this describes the position of the value that we look for in the array. So let's start with the implementation of this cut wood problem in Ask for Facebook interview. We are writing the test. First of all, cut wood test. We are defining the cut wood, and we are writing the setup method, creating the cut wood instance. And we are writing the real test. The real class. Checking for the corner case if the wood is length is 0. The smallest length can be 1, and the longest length can be the length of the wooden which is given array. For this one, we are writing another method to getting the max value of the given array. We can use integer max for the right value, but it's gonna be increase the time that we search for the element. As long as the right is greater than left, we are continue to searching in a binary search. For this one, we are just checking for the mid elements. Checking for the mid element is valid for the given wood and k. And we are deciding for which part we're gonna search, we're gonna continue our search, and we are adjusting a left and right values in the if clause. So we are writing these methods as well. We are just traversing through the array and finding the maximum element in the wood array. Run the test. And yeah, it works. And before leaving the video, please don't forget to subscribe my channel and thumbs up the video. Thanks for watching and happy learning.